Good morning, students. Well, it's probably not morning for you, but it's morning for me. Today we're going to look at graphing linear inequalities. Now, we've been solving compound inequalities and we've been using inequalities and we've been graphing them on a number line because there's only been one variable involved. But now we're going to be graphing linear inequalities where two variables are involved, the x and the y. It's very similar to what we did a couple weeks ago in graphing linear equations, but we're going to add a little twist to it. But the first thing that we need to be able to do is to tell whether a point is a solution to a linear inequality. So I have a linear inequality right here, negative x plus 2y is less than 8. And I have 3 points, 0, 0, the origin, 0, 4, and 3, 5. And I need to figure out if these in fact are solutions to this inequality by plugging in the x and the y to see if I get a true statement. If I get a true statement, it is a solution. If I don't get a true statement, it is not a solution. So let's plug in 0, 0. So if I have negative x plus 2y is less than 8 and I plug in 0, 0, I get 0 plus 2 times 0 is less than 8. And then I get 0 plus 0, which is 0. 0 is less than 8. That is a true statement, so this is a solution. Well, let's plug in 0, 4. I'll use a different color because of spacing issues. So I have 0 plus 2 times 4 is less than 8. Well, 0 plus 2 times 4 is 8. Is 8 less than 8? No, that's false. So this is not a solution. Now I bet you're wondering to yourself, well, if I had a less than or equal sign there, it'd be a solution. You're exactly right, but we don't, so it's not. And for the last one, 3, 5. With 3, 5, let's plug in 3, 5, and so I'm going to have negative 3 plus 2 times 5 is less than 8. So negative 3 plus 10 is 7. And 7 is less than 8. That's a true statement. So 3, 5 is a solution to that inequality. The next part of this whole process is graphing the linear equality and figuring out where we can find solutions to that linear inequality. So I'm going to take the problem that we just did, negative x plus 2y is less than 8, and I'm going to show you how to graph this inequality, and then we're going to see why some of these points are or are not solutions to it. So let's first of all pretend that there's no inequality sign, but it's actually an equal sign. And let's graph that line first. So I'm going to rewrite it as negative x plus 2y equals 8. And then we're going to figure out how we would graph that. Well, I'm going to put it in y equals mx plus b form, which is slope-intercept form, because that's, for me, one of the most efficient ways to graph a line, especially since it's not going to be a difficult process. So I'm going to leave the y where it is, and I'm going to move the x to the other side, and I'm going to get x plus 8 because the x becomes positive when it crosses the equal sign. And then I'm going to divide everything by 2, so I get y equals 1/2 x plus 4. That tells me that m equals 1/2 and b equals 4, so I'm going to graph that. B is 4, so I go up 4 on the y-intercept, and then my slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. Now, here's where I stop looking at the equation and I have to go back to my inequality. So this actually is going to be y is less than 1/2 x plus 4. Okay, notice the inequality, still the same. Because this says less than, I'm going to draw a dotted line. If it was less than or equal, I would do a solid line, but because it's just less than, I have to draw a dotted line to connect my points. And that is obviously a crooked line, but let me see if I can fix this a little bit. That's what happens when you don't use a ruler. So that is the graph of the linear function. Now we've got to figure out where our solutions are. So let's plot these points that we saw were and were not a solution. So the first one we're going to plot is 0, 0, which is the origin, and I'm going to put that in green. And that we said it was a solution, so I'll put a check mark. And then we have 0, 4. Oh, that's already plotted, but we said it was not a solution. And then we have 3, 5. 1, 2, 3, 1, 2, 3, 4, 5 right there. And we said that was a solution. So if we look at these points and we see where the solution is, notice that at this point, none of our solutions are on the line. There's a point that's on the line, but it said it wasn't a solution. That's because anything that's on a dotted line is not a solution. And in this case, the points below the line are all solutions because it says y is less than 1/2 x plus 4. So that's going to mean that everything less than this line is a solution to this inequality. And in just a second, I'm going to show you how we can figure that out from a different graph. But I just wanted to show you that, again, if I have a dotted line and there's a point on that line, it's not a solution. But because these points are below that line, all of these points down here, everything down here would be a solution. I could pick a random point right here, plug it in, and it would be a solution to this inequality. The next example I would like to graph is the inequality y is greater than 4x minus 3. And we're going to graph this and then figure out where the solutions are. Well, first thing we'll notice is that I have a greater than sign, which means that my line is going to be dotted. Write that down in your notes. If there's no equal part, it's dotted. If there's an equal part, it's a solid line. So we're going to graph it as if it was a linear equation. And so my slope is 4 and my y-intercept is -3. So I'm going to graph those things. We'll go to -3 for my y-intercept, which is right here. And my slope is 4, or 4 over 1. So from this point, I'm going to go up 4 and to the right 1, and then up 4 and to the right 1. And I'm going to, they've got 3 points. I'm good. But again, I have a dashed line. So let's see if I can do this decently. Okay, I kind of got off on the bottom a little bit, but that's all right. So now I have it graphed. Y is greater than 4x minus 3. Now, one of the things that we encourage you to do is always test a point to see where the solutions are. And we always like to test 0, 0. Is 0, 0 a solution to this inequality? Well, let's try it out. If I plug in 0 and 0, 4 times 0 is 0 minus 3 is -3. Is 0 greater than -3? Yes. So that means that 0, 0 is a solution. So I could kind of put a little dot here with a check mark next to it, which means everything on this side of my line is a solution. So to graph it, I actually have to shade in everything on this side because this point, 0, 0, is a solution, which means everything else on this side is also a solution. So here's our next example. X plus 2y is less than or equal to 0. Well, the first thing we notice, we have less than or equal, so my line is going to be solid when I draw it, which is a good thing to note in the beginning. But I need to get this to a point where it is in a graphable form. Right now, I can't pull out my slope or my y-intercept because it's not in slope-intercept form, so let's do that. So I'm going to leave 2y here because it's positive is less than or equal to -x, and I don't need to put the plus 0. It's just not there. So then I divide everything by 2. So I have y is less than or equal to -1/2 x, which means that m is -1/2 and b equals 0. So I'm going to plot this. I know that my y-intercept is the origin, and then I'm going to use my slope, -1/2. So I go up 1 and to the left 2, up 1 and to the left 2, up 1 and to the left 2. You only need 3 points. I gave you 4, just that's bonus. And now this is going to be a solid line because I have less than or equal to. So I'm going to try to draw a solid line through those points. And that's what I have. Now, I told you a few minutes ago that we always want to test a point, and if we can test the origin, that's always better, 0, 0. But in this case, the origin is on the line, so I can't use it as a test point, so I have to pick something else. Well, I'm going to pick 1, 1, just because 1, 1 is just about as easy as 0, 1, or 0, 0. But I'm going to pick 1, 1, and I want to see, is 1, 1 a solution to this inequality? If it is, then I shade everything up here. If it's not, then I have to shade everything down here. So let's check. 1, 1. I'll use a different color just to make sure. So 1 plus 2 times 1 is less than or equal to 0. 1 plus 2 times 1 is 3. Is 3 less than or equal to 0? No, it is not. So that means that 1, 1 is not a solution, so it's not shaded. Well, that means then that I have to shade the other side of the line, which would be down here. Because I know there's no solution up here, that means down here is where the solution. Another way you can look at that is I have y is less than or equal to. So typically when we talk about less than, we say everything that is below the line. Now that works 99.9% of the time, so you still have to be careful and test that 1 point just to make sure. So just to recap, I graphed my line. It was a solid line, and then I tested a point. And I tested the point 1, 1. Usually I test 0, 0, but since 0, 0 is on the line already, I can't use it. So I used 1, 1. I plugged 1, 1 in, and I found that it is not a solution to this inequality, so I have to shade everything where 1, 1 is not, and that is my solution. For your practice problem this evening, what I'd like for you to do is graph the inequality y minus 4 is less than x minus 6. Let's do a quick recap. The first thing you need to do is to get this in slope-intercept form, where y is by itself. Then you need to pick out your slope and your y-intercept and graph it. Now, if you don't like to graph that way, you can graph it any other way. You can create a table, whatever you want to do. Then you're going to actually graph the line. Make sure you know if it's dotted or solid. And then you're going to test a point to see if that point is a solution to this inequality. If it is, shade the area where that point is. If it's not, shade the other area where that point is not. Take a picture and turn it in using the turn in button below.